Any idea how to convert 56 degrees, 54 minutes, and 8 seconds to decimal? Okay. So, I'll give you a hint. You don't need to do anything with the degrees part. So that stays the same, 56 degrees. Because you're converting it to decimal, you're going to have a decimal point. Your challenge is to figure out what goes after that decimal point. So as I was saying before, if you understand that minutes and seconds are things out of 60, then you should be able to handle it. Okay? All right. So tell me what you know about a minute. Well, that's true. Okay. That's absolutely true. Tell me what you know about a minute with regards to a degree. So tell me what you know about a minute with regards to an hour.
Sorry, what was that?
Tell me what you know about a minute in regards to an hour. Very good. So 1 minute is 1/60th of an hour, or in this case, 1/60th of a degree. So you can use that information to get the decimal form of this. So this means 54/60ths of a degree. Now we can use our calculator to figure out what that is as a decimal. Our calculators work in decimal, so all we have to do is divide 54/60ths, and it will report the decimal version of that. So that's 0.9 of a degree, or 9/10. So we have part of the answer now, but we have to incorporate the last part here. So, another question for you, Celine. What do you know about seconds with regards to minutes? Think about time. Yeah. All right. Well, how many seconds in 1 minute? 60. So what this means is, or let me ask you another question first. 1 second is what fraction of a minute? 1/60th. Good. So this is 8/60ths of a minute. Does that make sense?
Yeah.
But we want to get a fraction of a degree. So, do you know what fraction of a degree 1 second would be? Okay, that's okay. We're all here to learn. Here's one way to think about it. There are, or let me put it this way. There's 1 minute, or 1 minute equals 1/60th of a degree. And 1 second equals 1/60th of a minute. So what you can do is you can use that information to figure out what fraction of a degree 1 second is. So 8/60ths minutes, we want it as a fraction of a degree. So we can make it over 60, because each minute is a 60th of a degree. Okay, so that's why I'm doing this over 60 again. This part here was seconds to minutes. This part here is minutes to degrees. .002, repeating. Another thing that might help you, Celine, is to know that there are 3,600 seconds in a degree. It's 60 times 60. Similarly, there's 3,600 seconds in an hour. Okay, so 8 seconds is 0.002 repeating degrees. So now we tack that on here. So it's going to be 0.902. And they only wanted it to the nearest hundredth, so it's actually 0.90. Okay? And there are other ways I could have explained that. If you're still confused on something, just ask, and I'll try another way. If I can't get it during the class period, I'll think about it more. You can come and see me outside of class. Okay, any questions on number 8? So to kind of like wrap it up, if you're asked to convert from degrees, minutes, seconds to decimal, you just leave the degree part. The minute part gets placed over 60, and then the second part gets placed over 3,600. And this is because each minute is 1/60th of a degree. And this one here is because each second is 1/6 or 1/3600th. Okay, any questions on 8? Next, number 9. We're asked to go in the opposite direction. We're given decimal, which is more of what we're familiar with, and we want to convert it to, you can call it Babylonian style. And let's get another random person. You and Jay, could you tell me how to convert 79.02 degrees to degrees, minutes, seconds, please? Okay. It is.
Well, the seconds represent that is 12 divided by 3,600.
Mm-hmm.
And the minutes represent that is 1 divided by 60.
Mm-hmm.
So then you get the common denominator, just to understand that up. And then you just divide what it would actually mean in decimal.
Okay. So it sounds like you're going from the answer, or a possible answer, to this. If you didn't have any of these choices, what would you do?
Even from them, you know that the minute is 1 divided by 60, which also gives you a reference point of how much each minute should be.
Okay. So if we do that, you get 0.017.
And you obviously know it can't be 2 minutes because then it goes over 79.02.
I agree with you. So it's going to be 1 minute something. Mm-hmm.
And then you start to go on the second and vice versa. It's the same.
Okay. How would you figure out exactly how many seconds it was?
1 divided by 3,600. And then you can just divide that from the actual number, which it needs to be, which is 0.02 minus the 0.016, which is kind of the difference between.
Okay. So that's how much we have left over.
And then you find a unit which is represented by the seconds.
Okay. Yes. So I will show you another way to do it. Leave the degree part alone. No need to change that. All you have to do is convert this to minutes and seconds. So what you can do is 0.02 times 60. And that gets you 1.2, or 1.2 minutes. So now you have the minutes part of it. So it's going to be 1 minute. Then to find the seconds part, you take this decimal portion here, the 0.2, and multiply that times 60. So in other words, you figure out how many seconds are in 0.2 of a minute. And there are 12. Okay, so 79 degrees, 1 minute, 12 seconds. If you're wondering why you can multiply by 60, I'll explain it to you. So you're trying to do well, you tell me, what is 0.02 as a fraction? Anyone? Just say it out loud. 2 over 100. Correct, or 1 over 50. And you're trying to figure out what that is over what? If you're trying to be all Babylonian about it. Over 60. Okay, so you're basically just setting up a proportion, or you are. And then you just multiply both sides by 60 to get to x. And that cancels. So you just do 60 times the decimal part. 2 100ths is the same thing as 0.02. And you do a similar operation here. 0.2. 0.2 is what as a fraction? Anyone? 1/5, or 2/10. So you're trying to figure out how many 60ths is 1/5. 5 times what is 60? 12. Or you could just multiply both sides by 60 to figure that out. Okay? So to recap, when you're given decimal degrees and you're asked to convert to degrees, minutes, seconds form, simply take the decimal part, multiply it by 60. The part to the left of the decimal is the minutes part that you'll insert. And then anything that's left over, which is a fraction of a minute, is going to be seconds. You take that part after the decimal, multiply that times 60 to figure out how many seconds are in that decimal part of a minute. There you go, you piece it together. Any questions on 9? Okay. So that was choice A. Number 8 was choice D. So I just wanted to add here why you can take the number of seconds and divide it by 3600. So we know that 8 seconds is 8/60ths of a minute because each second is 1/60th of a minute. Another way to think of that, or to just explore it mathematically, 8 seconds, I want to remove the seconds. So to use dimensional analysis, something you might have learned from chemistry, since you want to get rid of the seconds, you have to put it in the denominator here so it cancels. And then you can say that you want minutes on the top, for example. So we can use 1 minute, and then you have to do a conversion. Here, 1 minute is equal to 60 seconds. The seconds will cancel, and then you just multiply through. You get 8, multiply through here, you get 60. And then this unit stays the same. So that's how you can understand better how to convert from seconds to minutes. Let's say, though, you wanted to convert from seconds to degrees, which is the same thing as doing seconds to hours. So we start with 8 seconds, set up dimensional analysis, and I need to get rid of seconds, so I have to put that down here. Let's say I want degrees. So if I put a 1 here, just probably the easiest number to work with, then I have to convert that. I need a conversion. Well, maybe what's easier is to convert it into minutes first, like we were doing before. So 1 minute, 60 seconds. So that cancels the seconds out. Now I need to cancel out the minutes here, so I have to put minutes in the bottom. And then I want degrees now. So we'll still work with 1 degree. It's probably the easiest. And then there are 60 minutes in 1 degree. So this cancels with this. And now you can just multiply through. So you get 8 here, 60 times 60, which is 3,600. Recording. Now you are. Tell me please how I can draw 50 degrees in standard position.
You put the first line on the x-axis.
Which way? To the left or to the right?
To the right.
To the right. Good. And you got to tell me a little bit more.
The initial.
That's what you were referring to.
Yeah.
Yeah. Is there something else?
You gotta put the vertex at the origin.
You have to put the vertex at the origin. Okay, tell me more.
I'm not gonna get exactly 50 degrees, but I have to put the terminal side a
Mhm.
little bit, kind of a little more than halfway.
Very good.
On the x-axis, going to the right. Not on the x-axis, I suppose.
She means like from the
I
x-axis.
don't know how to explain.
So I liked how you said a little bit more than halfway. A little bit more than halfway between what and what?
Between the x-axis and the y-axis.
Okay, that I can understand.
Okay, great.
So I'm not asking you to use a protractor here. I think you all can use one. This is just to understand the concept of standard position, mainly. And I want to put an arc, because if I don't put an arc, it is ambiguous how many rotations it is. So there's my arc, and I'll also put a little arrowhead there indicating that it is a positive angle. Okay. Good. Any questions on drawing it in standard position? Okay, another random person. Jessica. I now want to find 2 other angles, one positive and one negative, that are coterminal with 50 degrees. Could you tell me how to find the positive one? Just 360? Well, if you just say 360, that's a complete rotation, so you end up here, which is synonymous with 0 degrees. You will involve 360, but the answer is not 360. So do you want to try again? Okay. So you don't want to be 360 degrees away from the initial side. You want to be 360 degrees away from the terminal side, because it's coterminal. Okay. So, 360 from there. Then you can just do it in your head or use your calculator. So the complete angle would be what, Jessica? Like, I want a final answer. So it involved using 360 degrees, but that's not the final answer. Because the answer that I provide is going to be an angle that's in standard position, which means that the initial side still starts from the positive x-axis. Okay, so you're just going to add 360 and 50 because you're going a complete rotation from this terminal side, which is 50 degrees from here. Hopefully that will make sense to you in the near future if it doesn't already. You're just doing a complete rotation from that terminal side. So 410 degrees is one of the coterminal angles. And another random person, Celine, could you tell me how to find a negative coterminal with 50? Okay, this is why we do this. So it's going to involve 360, because that refers to a complete rotation. Think of the hands of a clock. Like the hands on the clock up there. Let's just pick the minute hand. An hour from now, right, Celine, that minute hand will be in the same position, right? Because that's a complete rotation, an hour. Here, 360 degrees is a complete rotation. What we want, though, is a negative angle. So we're going to go clockwise or down, starting from the positive x-axis. Well, actually, we can use this to help us, but effectively, we want to go this way for like the final answer angle. So it's going to be some negative amount of degrees. This would be negative 90, negative 180, negative 270, and then you still have some more to go here. Celine, do you know how much this is? Yes. So one way to calculate it is to do 270 plus 40. All right. Or what you could do is take 50 degrees and subtract off 360, because that'll get you back around to it again. So that should be negative 310, right? There are an infinite number of coterminal angles with 50 degrees. We're just asked to provide 2. Any questions on 13? Okay. Let's try one more so I can get some more confidence that the class is understanding it. Amber, 160. How can I draw that in standard position?
Okay, well, 160 is pretty close to 180.
Mhm.
So the terminal side would be like past the y-axis and like
Mhm.
above the, like still above the x-axis.
Yep.
Yeah. Okay. Then your origin. The
So
vertex would be the origin.
I'm just going to draw the initial side in here.
And the initial side would be there. Yeah. And then you put your arc. Yeah.
Okay, good, thank you. Sue, could you tell me how I can find a positive coterminal angle with 160? Okay, this is why I do this. So it's just going to involve adding or subtracting 360 degrees. Because you're just making another rotation. You want the terminal side to end up in this same place. Okay? So just go another 360, like I was showing you on that computer demo, to get back to this spot. Okay? So does that help? Are you able to come to an answer? $500? $540? I don't think so. I think it's 520. That's the positive one. And Yoonjae, could you tell me how I can find a negative coterminal angle with 160? Minus what from 360? 160. Because now we want to go in the other direction. We want to come this way and figure out what that angle is. It's going to be a negative angle. Another way of thinking about it is starting from here, going a complete rotation clockwise and ending up here. And that's equivalent to subtracting 360. So I believe that's negative 200.
Yeah.
Question?
Okay, so let's say, okay, I don't know how to word this. Okay, like, let's say you have the measurement for an angle that's like above 360, but it's still asking for positive. You would have to subtract 360.
If it's just
because-
asking for a positive one, so I'll repeat the question. The question is, if you have an angle that's greater than 360, and you're asked for a positive angle, you can just...
Or like the smallest positive.
Oh,
angle.
that's different.
You have to subtract because.
Yeah, so for example, number 11 is more than 360 degrees away from like the positive x-axis. So in this case, because we want the smallest positive one, you need to subtract two 360s.
Why twice?
Okay? That's coterminal, but it's not the smallest one that's
Okay, it's still
coterminal.
bigger.
You can rotate again and end up there.
But like if that initial one were smaller than 360, then you'd be done.
Yeah.
Okay.
Okay?
Yeah.